Hello. So my name is Stephen Goddard. I'm talking to you about my series, Conducting Education Research. And today I want to talk very briefly about something that doesn't appear in my book very much, because I think it's a pointless thing to do, but it's something you will encounter when you read research, and that is significance testing and everything that goes with it. So what I should say is, despite decades now of learned organizations, bodies, journals and discipline areas basically saying don't use significance tests, or even in extreme cases, we're going to ban the use of significance tests. You can't publish them in our journal or whatever. It's still widely used. If you go and look at research involving numbers, obviously, people are using significance tests. It's not entirely clear why and why it hasn't declined more than it has. It has declined a bit over the 30 years I've been working in the field, but not, it's still widespread. When I talk about significance tests, I mean things like analysis of variance, t-tests, f-tests, and so on. And it's represented by p-values in papers, or sometimes asterisks or double asterisks or treble asterisks in tables of data. And it's one of those things that people put in and people read, and they think, oh, it must be scientific or it must be technical or whatever. But nobody really understands, or very few people seem to understand what it actually means and why they're doing it. So don't fall into the trap of using it. But more importantly, don't fall into the trap of believing it if other people use it. Just in your mind, just mentally rub them out. You can actually just, scrub them out with a pen, or metaphorically scrub them out so that you don't bother to read them. This normally doesn't change the story. It doesn't change the results that people are showing you. It's just a load of nonsense that people add into a piece of research. So let's just go the reason why, and we'll leave it at that. So the mathematics of conducting a significance test requires that the cases involved are fully randomized. Randomization is not something, a degree of something. You can't have more or less randomized. It's either randomized or not. So something has either occurred purely by chance or it has not. So as soon as you have any missing data, or any error in measurement, whatever, in the results, if anybody drops out of the study, then even if they were randomized to start with, your cases are not random. And of course, if you're using population data, that is all the cases are available, perhaps you're looking at the National School Census or something like that, then these have not been randomized. And if you use convenience or opportunity samples, which are all perfectly legitimate, they're not random. So, whether they're random or not to start with, I've never ever seen, either in my research or in anybody else's, a study that actually had randomized cases. So we could just stop there and say, well, actually, the mathematical requirement for conducting a significance test doesn't exist because they're never random. So you can't use significance tests otherwise. Because the purpose, or the reason people use the significance test, is to try and decide if their result is solely due to chance. But I have met people, apparently, sentient people, who would say, well, it tells you something, doesn't it, if you do a significance test, even if you haven't got randomized cases. So let's just follow that one through. So the assumption of your test is that the findings you got, your results, are due solely to chance, which is caused by the randomization of your cases. You don't necessarily believe that to be true, but you imagine it as true in order to do the calculation. And once you've assumed it's arisen by chance, then depending on what your data is, there are relatively simple ways to calculate what the probability is that you'd get a result as extreme as the one you got, and a difference as wide as the difference you got, or a trend as strong as the trend you got. And that's what you can do with the significance test. So that part is fine. Right? You can calculate, if you assume that the cases are randomized, what's the probability of getting the results as extreme as you got. But if you were doing it with cases that were not randomized, for whatever reason, then you know that the results you got are not entirely due to chance. because there's something other than chance that's gone into picking the cases or randomizing the cases to groups. So you know before you even start that it's not just solely due to chance. But if you do a significance test, what you'll try and do is to look at the probability of getting the data that you had, given that it arose by chance. If that's a small number, a very small number, you might decide that the results didn't arise solely by chance and conclude that something else has influenced the results other than chance. But if you started with cases that hadn't arisen by chance, then you already knew that anyway. You've gone through all the bother of a significance test to tell you something you already knew. It's completely pointless. It's just an absurd thing for people to do. It's a bit like if imagine you had an unbiased or fair dice that you could roll. So if you knew that the dice was fair and you rolled it and you got a 3, you could calculate, or a primary school child could calculate the probability that you rolled a 3, or that you would roll a 3 before you did it. You could predict there's a 1 in 6 chance of getting a 3. And if you rolled a 3 followed by a 4, you could predict that there would be a 1 in 36 chance of that happening, and so on. And you can do it for any number of die. I mean, it gets more complicated. You can use a computer and so on. But in principle, the idea is very simple. If you know that something arose by chance, you can calculate the probability of any result you get. But that's not what you want. So what you can't do is to say, I don't know if this dice is unbiased, and I've rolled a 3. What does that tell me? You don't know the probability of rolling a 3 because you don't know if the dice is unbiased. You could say, I'm going to assume it's unbiased, and therefore the probability of getting a 3 is 1 in 6. But that doesn't tell you whether the dice is biased or not. It's sort of no help in reality. The mathematical scenario works out as a probability, but you can't deduce anything from the result you get. And that's the same thing with a significance test. You can do it to calculate the probability, if it was all happened by chance, of getting the results that you got. But you don't want to know that, do you? What you want to know is the probability that the results they arose by chance, given the results you got. So given how big the difference is, did this arise by chance? But as with the dice analogy, it cannot tell you that. No? The probabilities of getting the data that you achieved, assuming it arose by chance, is one probability. The probability of it arising by chance, given the data you got, is a different probability. One can be very large and one can be very small, and you can't tell what one from the other. Knowing one doesn't tell you what the other one is. You'd need to know a lot more information and do some more calculations to convert one to the other, which are unrealistic in real life in research. So people just pretend, I think, that the first probability, the probability of getting the data you got if it arose by chance, is the same as the probability of the data you got arising by chance. And that's either dishonesty or incompetence, or possibly a mixture of the two. But it's like there's a resistance for people to throw away these toys because they think that they're going to somehow lose out. But as I pointed out at the beginning, if you do one of these tests and you haven't got completely random cases, it's not going to tell you anything of any value anyway. And the same logic applies to everything that's connected to or related to significance tests and standard errors. So power calculations, if you come across those, power calculations are to work out how many cases you need in your study to reach a certain level of significance. So they're built on those. Confidence intervals, can you find someone who actually knows what a confidence interval is or what it means? No, they're all based on this inverse logic that simply doesn't work in real life, however what good it might sound mathematically. So I would say just tell us the results of your research. Tell us how big the differences is. By all means, convert them to an effect size or use a sensitivity test to look at the sensitivity of the difference to missing data and things like that. But a good research design does not need complicated calculations at the end. If you take an extreme example like a randomized controlled trial, you get a large group, you randomize them into 2 large groups. The only difference between the 2 groups is that one group gets a treatment that the other group doesn't get. At the end, you test them, and one group might do better than the other. and you can work out how big that difference is. There's no tests involved. You don't need anything to do it. I mean, you might look at other things like the cost of the intervention or whether there's any side effects and so on. And you certainly should look at your missing data, but there's no technical way of deciding if the difference is high enough. So I really hope you'll take it from me. I wouldn't continue this any further. Significance test and all of the apparatus that goes with it do not work for the practical reason that you will never have a complete sample. But even in the case where perhaps in a laboratory, you have a 30-minute experiment with 16 students or something, even in that case where you haven't got missing cases or missing data, it's not going to give you the answer you want. It's not going to tell you the probability of the thing arising by chance. It will only tell you the probability of assuming it did arise by chance. And that's a different probability, and it's not going to help you. So don't use it. And as an afterword, by the way, you should think, if you rolled the 2 dice, or you rolled the dice twice and you got a 3 and a 4, would you be stunned and amazed by that? Because that 1 in 36 probability is significantly less than the 0.05 or 1/20th that is used in significance tests usually to decide whether something arose by chance or not. And yet, if you were playing a game at home, a board game or something, and your opponent rolled a 3 and a 4, you would not immediately shout, "Oh my God, that's so improbable. It must be not true. It can't have been chance. You must be cheating." Of course you wouldn't. It's absurd. No? And it's just as absurd as significance tests are. Don't use them. Don't touch them. Don't believe them. Thank you. See you next time.